let me tell you at the outset that I'm not a very crafty person. Some of you watching me do the work to build this rocket will be a little frustrated at how clumsy I am. But for the rest of you, I'll be a good surrogate to how you would be building the rocket. So I have everything I need. I have my design printed out from my open rocket design that we did together in class. I have my supplies. I have my parts in front of me. I have over here tools for cutting and gluing and taping and so on. And over here I have tools for measuring, rulers and protractors and so on. And I have, if I need it, the Handbook of Model Rocketry to look at how to do things. And I think I'm ready to go. So I'm going to start by building the motor mount. It's a good place to start. And here it is. My craft glue is a little old, and so that means that I've had to use white glue, which is not as strong, but I've used plenty of it, maybe too much, and that should hold fine. So we can see the centering rings, the 3 centering rings. We can see the tube in which the engine's going to go. We can see the motor retaining clip. What I'll do is I'll pry that clip back a little bit, slip the motor in, and then the clip will hold it in place. And then finally at the front, there's a little inside ring. There's a little inside ring which which retains the motor inside. When the motor fires, it'll be pushing forward. Partly it'll be pushing on the clip, and partly it'll be pushing on this ring, which will carry the load and propel the rocket forward. So now that I'm done with this, I can set it aside, and I think next I'm going to work on the fins. Now my design has the specifications for the fins. You may recall they were trapezoidal fins, and what I'm going to do is I'm going to measure and cut out shapes for the fins on an index card, and then I'll take my balsa stock and I'll lay that out there, and that will guide my cutting of the fins. That's next. Okay, now I'm ready to cut my fins, but there's something I need to remember. This is actually in the book by Stein & Stein, and I'll show it to you. The balsa, of course, has a grain to it. And the question is, how should I line up the fins with the grain? And it's tempting to make the grain run parallel to the rocket body, but that will cause the fins to snap off. And he says, if you do it that way, the fins will break and pop quite a bit. So he suggests that for strength, you should arrange the grain this way, sort of slanted with respect to the rocket body. So I want to lay out the fins on the balsa in that way. So there are my 3 fins. I cut them out, and I did a little bit of light sanding on them in order to smooth the edges, and especially to make the edge that's going to be next to the rocket body really smooth. And I'll put them and this in my little small parts bin so that I'll save the template in case I have to make some more fins later. Okay, and so what's next? Well, I think the next thing I want to do is I want to cut the body tube to the correct length. So here's the body tube I'm going to use, BT50 body tube, and it's a I need to cut it to a length of 30 centimeters. That's what we decided to do for this rocket. And so let's measure that out. 30 centimeters, of course, is about a foot. We'll go from this end. Okay, go from that end. 30 centimeters brings us to here. Now I want to make this line all the way around the tube and to cut around the tube in a very smooth way. Luckily, there's a little widget that's going to help me. This is a little guide. I can slip it over the tube to where it needs to be. And then when I squeeze it together, it should hold pretty steady there, right? So it's held around the tube right at the place where I want to cut it. So I can draw a line with my pencil around the tube. In fact, I can use this as a guide for actually cutting the tube. Cutting the tube is kind of tricky, and so it's helpful to have a tool to make it work. Well, it's not the neatest and cleanest cut that was ever made by human beings, but it'll do. So now the body tube is the correct length. The next thing we want to do, I think, is to attach the fins to the body tube. And so we'll do that using a little widget I designed, we'll be able to put this on here and attach the fins one by one. But to do that, we need to mark where we want to put the fins, and luckily there's a little tool for that. It's a little thing which has the fin locations marked on it, and I can set the body tube down on it, and I can make marks for every 120 degrees for the 3 fins. Now, that gives me just where the fin should go, but I'd really like to put a line along here that would let me line up the fins really well. And I have a little tool for that. This is a kind of a right angle ruler. I can place it here, and then there's a slot on this side through which I can make a pencil mark. So I can just rotate it around so I can see the mark I want to mark, and then draw a line and go to the next one. Draw a line, and I can go to the next one. And so now I have the positions of the fins clearly marked by pencil lines. So let's glue on the fins. Okay, now the fins are on. We have to wait for the glue to dry. Meanwhile, we'll start thinking about the recovery system, the shock cord, and the parachute. Okay, so here I have the parachute and the shock cord and the nose cone. And the first thing I noticed is that my shock cord is actually a little bit longer than the one in my design. I designed a 40 centimeter shock cord, but this one is 60 centimeters long. Nevertheless, when I found the mass of it, the mass of this is almost exactly the same as the mass of the shock cord before. And in any case, the shock cord is only about a gram and a half, and this is 1.5 grams instead of 1.4 grams. I think it's fine. So I'm not going to shorten the shock cord. I'm just going to use it as it is. It's a, so how do I do? Well, I'm going to have to attach it in the middle to the parachute, and on each end to the body tube and to the nose cone. Let's do the parachute first. So I have the parachute, and it has these the shroud lines already attached, and you'll notice that the shroud lines come in pairs. So these two adjacent shroud lines are connected together, and so on. So if I pull this out, I'll have 3 closed loops, and I want to attach these things to the middle of the shock cord. Well, how am I going to do that? Well, one way to do it is just to do the old trick where you make a loop in a piece of string, and then you bend the loop over, and you have a kind of a slip loop. So let's see. Let's get the parachute about right, and we'll take these and we'll bend them over like so. And so now that can tighten onto something and tie onto it. And so I can just run the shock cord through there. And now tighten it down. And now the parachute is well attached to the shock cord. Now, to attach the shock cord to the nose cone is no problem. There's a little loop on the end of the nose cone for this purpose. I can run the shock cord through, and then just tie a knot. So that's going to be really easy. I'll use a good knot. That same little loop at the back of the nose cone is where I'm going to attach the altimeter with a little metal clip. But the other end of the shock cord needs to be glued to the inside of the body tube. And that connection has to be really good, because that's what's going to, the shock cord actually jerks out, and it needs to really stick to that inside of the body tube so that the rocket can come down on the parachute. So how am I going to do that? Well, what I've done, this is an easy way to do it. There are lots of ways. What I've done is I've taken a piece of index card, and I've cut a little trapezoid, and I've bent it in 3. I've bent it one way and then the other way, so I have a trifold here. And what I'm going to do is I'm going to run the shock cord down one way, like so, and fold it over and glue the heck out of it, and then bend the shock cord back around, fold it over again, and glue the heck out of it. So now I've got a glued together sandwich, 3 layers of paper, 2 layers of shock cord, and I can take the whole thing and I can glue it on the inside of the body tube, and this thing will hold like crazy. So this is a nice way to make sure the shock cord is not pulled free of the rocket body when the parachute deploys. And now we're just about done. Here we have the parachute attached to the middle of the shock cord, and the shock cord at one end is connected to the nose cone, and at the other end to that little thing we just made that's going to glue to the inside of the body tube up near the front, maybe an inch or 2 back inside. So now it's time for final assembly. We'll attach this to the inside of the body tube at the front. At the back, we'll glue this, the motor mount assembly, in the inside. We'll put glue on it and slide it into the right place and let it sit. And then finally, we'll add the launch lug to the outside, about halfway along the rocket, not in line with the fins. And we'll glue all these things and we'll let it set. And there it is. Not bad. of course, everything's all attached. I'll need to fold up the parachute and so on. And probably, before I fly it, I'll give it a coat of paint. Nothing fancy. I have some spray paint. And we'll be ready to go. But first, I want to do something else. I want to do a test of the aerodynamic stability of my design. I want to put my design in the wind tunnel. And I want to have the mass distribution just as it will be. So I'll put a motor in the back and I'll put the altimeter in the front. Now the altimeter has to attach to the nose cone so that it doesn't just fall out onto the ground. And there's a metal clip for that purpose that comes with the altimeter. And so I'll attach the altimeter to the clip and I'll make the clip closed. Yeah, and then I'll just be able to assemble it. First, roll up the parachute very nicely, tuck in the altimeter and the shock cord, and then put the nose cone on it, and put a motor in the back, and I'm ready for my my aerodynamic test of my rocket design. Okay, here we go. To tell you the truth, I'm a little nervous because if it's not aerodynamically stable, I have to go back and fix it. Probably make bigger fins. But let's see. I think we're fine. Now we'll paint it. Okay, there it is. As soon as the paint dries and the glue really sets, it'll be ready to fly. Unfortunately, the forecast is for rain this afternoon. But when we do fly it, we'll be able to use the altimeter to measure its trajectory in time and to compare that with the simulated trajectory that we got from OpenRocket. I've found the mass of this rocket, and it masses something like 54.5 grams. Now, the OpenRocket prediction was that the mass would be about 50.5 grams, so it's about 4 grams heavier than the design anticipated. But that's easy to see why. I've got a couple of small metal clips, the motor retaining clip and the clip holding the altimeter that I didn't take into account, and there's also a coat of paint. So it'll be interesting to see how the actual trajectory through space, how the maximum altitude, for example, compares with that we found by computational methods. So stay tuned, and we'll see how she flies.